Hello, I'm Reels. In this video, we are going to make a procedural anime eye using shader nodes. So no drawing, no plugin, and it works in both Cycles and Eevee. Also, you can bake it into image texture or just straight up use it. The summary for the eye content, we start with the core node, a custom mapping node. This node basically gives us control over the texture coordinates, things like location, rotation, and scale, but with the pivot right in the center. Using this node, we begin creating the sclera, which is the white part of the eye. After that, we build another custom node group called dot composition. This gives us controls over thickness, sharpness, scatter, and opacity. We'll use this as a helper node alongside the center gain length to create more detail in the eye. Next, we start building the main eye structure. Start with the pupil, then outline ring, and the cornea edge. The cornea edge is then refined using a mask, so we can get a more interesting shape. Then we move on to the iris. First, we create a circular gradient as the base, then we make iris stripes from it. After that, we give the colors, then finally we add the dot-like effect. Oh, I almost forgot, I will also show you some other eye designs variation that you can create with the shader. Alright, that's all the step, let's go. To make a simple dot in the center, we can use texture coordinate and calculate its length. So, add a texture coordinate, then take the generated output and connect it into vector length node. Then plug it into principal BSDF. As you can see, there is nothing happen here. If we mute the length node, we can see that the texture coordinate pivot is not at the center. Currently, it's on the bottom left, which is 0 for all coordinates. To center it, usually we'd use a mapping node, then adjust the location value to -0.5. But there is a problem. It looks like we shift the pivot to the center, but it's actually not. If we try to adjust the scale or the rotation, it's not around the center, which is the pivot is still at the 0. This can make the setup less convenient later, so let's make a manual mapping that have center pivot. So let's remove this mapping node, then let's start by making the pivot center first. We know that center position is at -0.5 from mapping node. That means we just need to shift it using subtract node by 0.5. There you go. So yeah, addition or subtraction is basically how we shift or offset the texture coordinate. Next is we want rotation control. We can use vector rotate, then change the type to Euler. Then you can adjust the rotation here. Yep, it works well. Next is the position or location control. We can use subtraction or addition. As you can see, it works well like I explained previously. So yeah, we use this add factor to control position later, not the subtract node. Subtract is only for centering. Then finally, the scale. So scaling basically changes the distance from the pivot without shifting the pivot itself. We can do this by multiplying the factor. So pivot at 0 will stay 0 and everything else scales inward or outward. As you can see, the green, yellow, and red colors shift closer to the center, and the outward part start giving white color. That means we successfully increase the range. We'll reuse these nodes a lot, so I'll group them. You can skip this part if you already know how. Press N to bring out group properties, then I'll name this group center gain length and give it input for the color tag. In the group sockets, this is for the output. We leave it float data type as is. Then over here we have some group input node for making some input data. I'm not going to add input for the centering subtract. You can add it if you want. We're going to add the input for the rotation. Then I'm just going to delete the description and leave it empty. Then the add node and then rename it to location. Then lastly the multiply factor for the scale. In the group sockets input, you can modify all of the default value and their min-max value if you want, but I'm just going to leave it as is. If you don't, click this button to go back to the main shader. If you want to edit the group node again, just press this button. That's it, you can try all of the input to make sure it works properly. With this node, we can start making Sclera part. We just need to add color ramp after this node. Then I'm going to frame it and name it Sclera. Now we just adjust these values in the Sclera frame to make it looks like an anime style Sclera. What can we adjust? Well, we can change the color ramp interpolation, drag the color ramp handle, add more or remove the color ramp handle, and adjust the center gain length values. Now I have my setup ready off screen, so let me just show you how my setup, just to save your time. Here is my setup. Feel free to follow it if you like, or use it as a reference for your own setup. The key idea for this design is use the scale and the rotation to curve the shape. Oh, and make sure you don't use full black color, so it can be tinted later, unless you don't want it to be tinted. These are the rest of my color ramp values. Pause the video if you want to match them exactly. Okay, let's add some small helper nodes so we can create more variation of the center gain length. Let's copy this center gain length, then reset all of the values. We are going to make thickness, scatter, sharpness, and opacity. Plug the center gain length into the principal BSDF base color to just see what happened. Now let's start with thickness. We're going to use subtract node. The function looks like scale, but it actually affects the gradient. In this case, you might not really see the difference, but it will make sense later. Now we need to enable the clamp, so the value not going negative. Next is scatter. We can use math power operation. Enable the clamp as well. In this case, the lowest value we can use is not 0, but 0.001. Why? Because center gain length is a radial gradient from 0 to 1. Since the center is black color or a 0 value, anything to the power of 0 becomes 1 value or white color. So yeah, we stop at 0.001 so the dot doesn't turn white. Next is sharpness, or the operation to reduce the scatter spread. We are going to use multiply node and also enable the clamp too. We'll set 1 as the default. Now if we increase it, it reduces the scatter spread. This happens because everything except pure black gets pushed towards white. Next is opacity, so 0 opacity turns everything white while 1 shows the black dot. For this, we can use a mixed float node. We plug the multiply threshold into slot B so the factor of 1 displays the black dot. Set slot A to 1 so that 0 factor outputs white. Now we have precise opacity control using this factor value. Alright, now let's turn these nodes into a group. If you already know how to do this, feel free to skip ahead. I'll name the group .composition and set the color tag to converter. We'll start with the subtract node. This value we want to subtract comes from center gain length, so I'll name it .length. I'll keep the type as float, since center gain length outputs a float. Next is the value that subtracts center gain length. This is what we previously called thickness. We'll leave its setting as is. Next is power node exponent, which controls scatter. Set the minimum value to 0.001 and leave the rest unchanged. Then we have the multiply node, which controls sharpness. Again, we'll keep the default settings. And finally, the mix node, which controls opacity. We only need the factor input, so plug that input in and name it opacity. Oh, I also removed the description and leave everything else as is. Alright, that's it. Let's test it. Good, everything is worked perfectly. Let's create the pupil using these two custom nodes. But first, we need to add a color ramp after dot composition. Okay, so with this color ramp, we're going to shape the gradient so the pupil looks like it has a subtle glow effect. Now, before we do that, we need to increase the dot composition scatter value. We need to do that because the color ramp needs a wider gradient range to work with. Then finally, we can start tweaking the color ramp. Let me do that off screen, so you can just copy it if you want. Here you go. Pause it if you'd like to copy the exact color ramp settings. Okay, that's it for the color ramp. Let me adjust the scale a bit. Now we can combine this part with the Sclera part. We can just use math multiply node to do that. Then also enable the clamp. Okay, that's it. Let's frame this node and name it Pupil. Okay, next we're going to make outline edge. We can copy these two custom node again, then paste it up here. Now to make the outline, we can use absolute operation math node. Place it after the center gain length node, then try to connect it to the principal BSDF color. You'll notice nothing happens, even after you toggling the absolute node. Well, that's because center gain length doesn't contain any negative values. To fix it, just subtract it until you get negative values. This time, don't enable clamp, so the output isn't restricted to 0 and 1, but we can enable it for the absolute node. Next, plug the absolute result to the dot composition, then to the principal BSDF color. There you go, the outline edge. Now we can see the thickness function more clearly. Let me adjust the scatter a bit, and that's it. Now we can frame it and name it outline edge. To combine it with the previous multiply node, we can use multiply node again. We use multiply because our data is still raw 0 and 1. But if we have color like RGB, that is different story. We'll get to that soon. Alright, now let's make some cornea edge. We can just copy the whole outline edge frame. Make some space here, paste it here, then rename it to cornea edge. Then combine it using math multiply again. Then we can adjust all of the values inside this frame. So yeah, we can treat this frame as a new part. Feel free to add more shape or experiment with the other node or frame as well. In the next part, I'll show you how to customize it further. Alright, first let's move this down here. Now, to customize our corner edge further, we can change the dot composition flat value into texture coordinate gradient value. Plug this first to just see what happens. In this case, we'll be adjusting the thickness and opacity parameters. To give it texture coordinate gradient, we can use our center gain length node. So let's duplicate it. Alright, let's create a top to bottom gradient from this. Connect it first and reset all of the values. Then I'll set the X scale to 0 so the gradient becomes a horizontal line. Then reduce the Y scale to a small value to stretch it vertically. Then we refine the gradient using a color ramp. Bring the white and black handles closer together to compress the transition range and make the gradient sharper. I'll set the interpolation mode to ease, then shift the position downward to adjust the transition area. Observe how the black area aligns with the bottom part of the ring. Now let's plug the opacity input using this color ramp. There you go, we have the color ramp values are now driving the opacity input based on the position of the black and white handles. Cool. Let's frame it and name it cornea edge mode before we continue. Let's try to do the same thing to the thickness. Add another color ramp first, place it inside the frame, then let's try to just plug it. As you can see, it is affecting the thickness the same way as the opacity, but the value is just too large. That's because our color ramp is outputting pure white, a value of 1, while the default thickness value was only 0.03. So let's correct that. And of course, you're not limited to the default values. Feel free to use whatever value you'd like. You can also add a multiply node after the color ramp to gain additional control over the intensity. Feel free to experiment. Now we just need to tighten the color ramp handles. And I like to change the interpolation to ease. Then we can also tweak the rotation a bit. That's it. You can also rename the color ramp node to whatever you'd like. It's completely optional. Alright, let's make iris part. With this kind of shape, a circular gradient as the base data would be nice. To make that, we need angular data. We can create it from our center gain link. Let's duplicate it and paste it right before the principal BSDF and connect it. Then we make this node into a brand new node by clicking this number button. Then rename it into circular gradient. Reset the values. Then click this small button. Now we don't have to make the node from scratch. We just need to modify it. We can keep our center pivot, rotation, location, and scale. Because we're trying to get the angular data, we don't need this length node. Instead, we need the x and y components of the texture coordinates. Currently, we have the vector data, so let's separate it with separate xyz node. Now we have horizontal from the x output and the vertical is from this y output. With these x and y outputs, we can apply it into an arctan 2 to make the angular data. There you go. From here, you can add some angular field modification. like shift it with add or etc. But we don't really need it for this case. Feel free to experiment it. Okay, let's make the iris stripes from this. We can use math cosine operation to create it. Let's add it and connect it. Right now, we don't see any wave pattern. Well, that's because we haven't introduced frequency yet. Normally, if the mask is based on texture coordinates, we can simply use scale to increase the frequency. But that won't work in this case. This is because the arctan2 operation always outputs a directional value normalized between 0 and 1. So, let's put the multiply after the arctan2 operation. Also, make sure clamp is disabled. Then we can add a value node and name it stripe frequency, just to make it easier to keep track of what this value controls. I'm also going to invert the cosine result so we have more control over the white areas. We can do this by using a one subtract node. And don't forget to enable the clamp. Next, we can put our custom node.composition if you'd like to further customize it. Yep, this node is optional for this case. Finally, we can frame it and name it iris stripes. Let's mask these iris stripes into a ring. You probably already know how to do this. Yes, sir, we have Cornea aids for that. Let's just copy the whole frame and paste it down here. Then rename it to iris ring mask. Let's plug the ring into the principal BSDF color for a second. Currently the ring is black color. I want to invert it into white color. We can use one subtract node for that. Now we can just multiply it with the iris stripes. There we go. Now we just need to adjust the ring values. I've already done that off screen, so let me just show you the result. Here is the result. Feel free to copy the settings. Now I'd like to add another mask for the opacity. Yep, we can use the same method we previously used for the Cornea Edge mode frame. Again, we can plug it into principal BSDF color to see what happens when we try to adjust the value. And of course, I've already done that off screen, so let me just show you the result. Here you go. Feel free to copy the settings. Now we can frame it and name it iris ring mask mode. Then let's test it. Finally, we just need to combine it with the previous multiply node. We can use mix float node. Let's give it color. This is actually very simple. We just need to add mix color node after the mix float node. Plug the mix float result into the mix color vector. Then you can just choose whatever color you'd like. I also like to add some overlay to my color. This is just personal preference. So yeah, that was basically it. We can just frame it and name it coloring. Okay, for the finishing touch, we are going to give it dot like effect. This is actually very simple. We just need center gain length and dot composition. Let's put this into a frame and name it bottom dot like, since I'm going to put this dot like at the bottom later. So yeah, name it any name you want. I'm going to make two more of these, so I'll just duplicate it and name it quickly. After we're done duplicating, we need to combine every dot like. We can just use multiply node. Then plugged it into principal BSDF color to just see what happened when we adjust the value. Again, I've already done that off screen, so let me just show you the result. Here you go, feel free to copy it. Finally, the last node to combine everything is just mix color node. Just put the multiply dot like result into vector input. Change one of the color to see which one is the background, then plug the main result into that. And that's it. There are actually a lot of variations you can create with each frame. Here are a few quick variant settings I made, hoping they can help you understand the shader better, or at least give you some reference for designing your own eye style. Pause it if you need to. So yeah, basically you can add more frame combinations node, introduce additional masks, or even remove some parts entirely. Alright, I hope you learned something new. Cheers!